Welcome back. We created two examples using Kafka as a source. In both examples, we were reading invoices from Kafka. However, we performed two different sets of processing. In the first example, we flattened the invoices and sent the output to a file sync. In the second example, we created a notification record and sent it to a Kafka topic. However, in both examples, we are reading the same invoice from the same Kafka source. Now the question is this: do we really need two separate Spark applications? Can't we run two streaming queries in a single Spark application? We can do it. In fact, it makes a good sense to implement multiple queries in a single application if you need the same input for both the queries. For example, flattening the invoices and generating a notification can be done in a single application. And by doing that, we will be reading invoices from Kafka only once, which will save some time and resources, right? Let's do it. Here is my new example project. I copied code from both the earlier examples and created this one. Let me explain. I'm creating a Spark session. Then I'm defining a schema for my invoice. The next step is to read the invoices from the Kafka topic. All this code is the same that we created in the previous example. The fourth step is to extract the value field, apply the schema, and create a data frame. Up to here, things are common for both the requirements. The next step is to implement one of the requirements. I'm taking the notification requirement first. Implementing the notification requirement was a three-step process. The first step is to create a notification data frame. Then we transform it into key value columns and get the Kafka target data frame. Finally, we create a Kafka sync query and start it. That's all. The first query is done. But we do not start waiting for this query to terminate. Instead, we start implementing the next requirement. Flattening requires a three-step process. The first step is to explode the value data frame and get the exploded columns. Remember, we are reusing the value data frame here, right? The second step is to create the flattened records. Finally, we create the second query for a file sync and start it. Now both the queries should run in parallel as long as you have enough resources to do it. However, you must wait for the driver thread for the background process to complete, right? But a multi-query application should not wait for a single query. Waiting for one of the queries will halt the other queries. Spark gives you another option. You can use the Spark session.streams object and wait for any of the queries to terminate. Both the queries are going to run forever, and one of those will terminate in only two possible scenarios. The first possibility is an error condition, when one of the queries fails to raise an exception. The second scenario is to manually stop the application for maintenance. In both cases, your application will stop, and both the queries will also stop. There is one more super critical point to remember here. Each query should have a unique checkpoint location. I'm not sure if you noticed it here. The notification query is using this checkpoint, and the flattening query is using another different checkpoint. Two queries cannot and should not be using the same checkpoint. They are running from the same application, or you have two different applications. Every query is identified by a unique ID in the Spark cluster based on the checkpoint location. So your checkpoint location must be unique for every query in the Spark cluster. Great, that's all for this video. See you again. Keep learning and keep growing.